Hello viewers, welcome back to another section of my multivariable calculus tutorial. In this video, we're going to solve limits of multivariable functions. I have two problems here which we're going to go through. If this is your first time visiting this channel, don't forget to like, subscribe and also share as well. Kindly watch this video as I take you through the steps in solving these problems. So let me take my first one, A. I have the limits as x, y, and z approaches 2, 1, and negative 1 of the function 3x squared z plus yx cos of pi x minus pi z. When you say limit of any function, it means that how is the behavior of this function as we are approaching this particular point. In the three-dimensional space x, y, z, you can approach a function from different dimensions. Unlike the 2D where we have the right and left limits, that is, you can approach a function from either the left side or the right side. In this case, we can approach it from different dimensions. You can approach it through a line, through different curves. And the rule is, wherever you approach this function at this point, you should get the same answer. But in this case, we don't have anything that's going to make this undefined. So we can see that this is a continuous function. We don't have anything that's going to make it undefined, so you say this is a continuous function. And for every continuous function, the limit point is equal to the functional value. The limit point of every continuous function is the same as its functional value. So what we are going to do is, we are going to put these values into the various variables here. So I'm going to have 3 open brackets. Wherever I see x, I'm going to put to the squared z, which is negative 1, plus the y here is 1, the x is 2, then cos, open brackets, pi, my x is 2, minus pi, and my z is negative 1. And further simplify this, I'm going to get here 4 times 3, which is 12. Negative 12 plus 2 cos of the expression, 2 pi minus pi. This further simplifies as negative 12 plus 2 cos of the expression, cos of pi. You can go further to break this down, or you can also leave it this way. So we are going to get this solution as our functional value, which also is the same as the limit as this function approaches this particular point. Let's go to the second part, that's the B part. Limit as xy approaches 0, 0 of x squared y squared all over x to the power 4 plus 3y to the power 4. When I have this rational function, the function or the limit of this particular function can be equal to its functional value provided it is continuous. But we realize that if x and y are zeros here, the function will be discontinuous. Therefore, the limit cannot be the same as the functional value. That is, when I put 0 squared multiplying 0 squared all over 0 to the power 4 plus 3, 0 to the power 4, I'm getting 0 over 0. And this is a discontinuity. Therefore, how do we do it? Take note, as I always say, in single variable calculus, we take the right limit and the left limit. But in this multivariable, since it's a 3-dimensional space, we will take lines. Basically, we take x equals 0, y equals 0. You can test for y equals x. You can test for y is equal to 2x, or even a curve y is equal to x to the power 3. But in all cases, you are supposed to get the same answer. If it happens that you got this to be 0, you got this to be 1, then it means the limit of this function doesn't exist. Now, let's test for any of them. So let's take s equals 0. So if s is equal to 0, I'm going to get 0 multiplying y squared all over x, that is 0 to the power 4 plus 3y to the power 4, giving me 0 as a limit point. Therefore, I can go ahead to test for y equals 0, and obviously y equals 0 will also give me 0. Now let's test for y is equal to x. If y is equal to x, what are we going to get? We are going to get x squared multiplying x all squared all over x to the power 4 plus 3 open brackets x to the power 4, and this is going to give me x to the power 4 at top. I'm getting x to the power 4 plus 3x to the power 4. This is also equal to x to the power 4 over 4x to the power 4. I can cancel this out and I'll be left with 1 out of 4. That is, this will cancel this. Since the limit as this approach 0, x approach when x is equal to 0 give us 0, y is equal to 0 is giving us 0, and when we found the limits when we are approaching it through the line y is equal to x, giving us 1 over 4. You can see there is differences. Let's still go ahead and test for when y is equal to s cubed. So if y is equal to s cubed, let's see, wherever I see y, I'm going to put s cubed there. So x to the power 2 multiplying s cubed to the power 2 all over x to the power 4 plus 3 s cubed to the power 4. What am I getting? This will give me x to the power 6, so x to the power 8 over x to the power 4 plus this place will give me x to the power 12, so 3x to the power 12, and this is the same as x to the power 8 over, so I'm going to factorize x to the power 4 out, so x to the power 4 1 plus 3x to the power 8, so this will be x to the power 4 up here all over 1 plus 3x to the power 8. So if I take the limit as x approaches 0, you realize that you get 0 over 1 plus 0, and that is giving me 0. Now you've realized the limit points were different for each of the paths we took. Therefore, the limit of this function does not exist. So if you take different paths, you should arrive at the same answer, and that wasn't so. Thank you for watching this video. Kindly subscribe and don't forget to share.